Let's put everything back together. Suppose you are given a polynomial and they are asking you to find its zeros and their corresponding multiplicities. How can we do that? Well, first of all, we shouldn't be just looking blind. We should be using what's called the rational root theorem first. What does it mean? Well, we're going to look at the last number, which is 64 here. So we're going to write that down, 64. What are the factors of 64? Now, they're always going to be plus or minus, and usually I just write plus minus in the front. Okay, let's just open a calculator and see if we can find those factors. Now, always going to be 1 itself. So 1 and the number. So 1 and 64 are, of course, are factors. That's always going to happen with any number. How about 2? So let's divide 64 by 2 and see if the answer is an integer. Yes. So 2 and 32 would be also factors. Okay, how about 3? Well, that's not happening because we got a fraction, right? What about 4? 4 is actually going to work. So 4 and 16 will be possible factors. Are there any more? Well, 5 not going to happen because it's not divisible by 5. How about 6? No. 7, no. 8, yes. And the 8 is actually 8. And that's about it. I mean, you can try some of the other ones like 9, 10, 11, whatever. You will see that nothing is going to work. Okay? So these are all the possible factors, but what we did now is we narrowed down the possible zeros to just these numbers. But remember, they could also be negative. So it's a plus minus thing. So it's going to be 1, 2, 4, 8, 16, 32, 64. Okay. So once you got all possible ones, the next step is to say, okay, how do I know which of these is the actual zero? Okay, so let me write down the polynomial that we started with over here, and then I'm going to switch to the calculator and show you what to do next. Basically, what you need to do is figure out just one of them, and then you will be able to reduce the power from the cubic to a quadratic, which is going to be pretty easy to solve, hopefully. All right, so for this polynomial, I'm going to replace all x's by empty parentheses, okay? So just bear with me, this is what I'm doing. The next step is to try these zeros. And usually the way these questions work is that you hopefully will not have to look for long. Okay, so let's start with 1. So inside the parentheses, let's put 1. Is that giving us 0? No, it's not, so that means 1 is not the actual 0. How about negative 1? So we'll just switch it to negative 1. No, we don't get a 0. Okay, so that doesn't work. How about 2? Inside the parentheses, we'll just replace it with 2. Not working. How about negative 2? Hopefully we won't have to look for longer than that. That doesn't work either. Oh my God. Okay, let's try 4. You have to be methodical. Like this is the only thing you can do. And 4 works. You can see that 4 gives you 0, which means that we already found 1. Once you find 1, you are able to reduce the question to a quadratic by using synthetic division. Okay, so here's how that is going to work. So I'm going to write down the coefficients of my polynomial. So 1, negative 4, negative 16, and 64. And let's see if we can find the quotient. Okay, so first bring the 1 down. Then we're going to multiply 1 times 4, that's 4. Add these up, negative 4 plus 4 is 0. Multiply 0 by 4, that's 0. Now add these up, negative 16. Multiply negative 16 by 4, which is going to be negative 64. And finally, when you add them up, the answer is 0. Now that you already know, because you were able to figure out that when you plugged 4, you got a 0. Okay? Now, what is going to be the quotient? Well, the quotient is this part. Okay, so we were able to write down our polynomial as x minus 4. Why, by the way, is minus 4? Because the factor corresponding to x equals 4 is x minus 4, because that's when it's 0. If you set x minus 4 equals 0, you get x equals 4, right? So remember to put a separate, the opposite sign. Okay, now here, what's the quotient? Remember, we started with the cubic polynomial. When you divided it by one factor, now you got a quadratic. So this means that this is going to be x squared, this is going to be x, and that's the number. So we've got x squared minus 16. Can we factor that? Now, here we're going to review something called difference of squares and how to factor difference of squares. And this is actually pretty easy. easy. So whenever you have something like a squared minus b squared, this factors as a minus b multiplied by a plus b. So why am I saying that that's what happens here? Because you can see that this is x squared minus 4 squared, right? Because 16 is 4 squared. So that's going to factor as x minus 4 multiplied by x plus 4. Okay, so we are basically done, but notice how this particular part, we have two repeating factors, x minus 4 and another x minus 4. That could be written as x minus 4 squared. Okay, so this is going to be, this arrow did not work out the way I wanted it to be. So this is x minus 4 squared multiplied by x plus 4. Okay, so now this is the final answer. If we factored our polynomial, but what we want to do is figure out what are we going to put in the table. Well, x minus 4 is equal 0 when x equals positive 4, right? So positive 4 is going to be one of the roots, and the multiplicity is 2, because this power right here is 2. The other one is x plus 4, that is 0 when x equals negative 4. And multiplicity of it is 1, because it's like power 1 right here. You can assume that that's what's happening. Now, why did I write negative 4 first and then 4 is because that's what they want me to do. They want to order the zeros from smallest to largest. So I had to list negative 4 first, and then 4 would be the next line.